Welcome back to math class. This is the Test 2 study guide. I am Mrs. Witt, and I'm going to be working through this just to help you prepare for the test so that everyone is confident that they have reviewed all the material and they know what to expect. So first we need to know that there's a whole list of terms and ideas and concepts that we need to understand what their definition is and how we use them. So our first one is numerator, denominator, and common denominator. So let's just remember that if we have a fraction like 1/2, the number on top, so the top number is the numerator, the bottom number is the denominator, and if we have a common denominator, that common denominator means like if we're adding something together, let's say we have 1/3 plus 1/2. Well, we have to have a common denominator, meaning we have to, when adding and subtracting, that bottom number has to match in order for us to be able to use it. So I would need to change them to the same thing, something common on the bottom. So I noticed that I can find the easiest common denominator by multiplying them with each other. So 3 times 2 is 6. So to turn the 3 into a 6, I had to take it times 2 on the top and the bottom. And the other one I took times 3 on the top and the bottom. So that changed this into 2 over 6 plus 3 over 6. And now I can add them. Well, I just keep it over 6. I have 2 pieces of 6 and 3 pieces of 6. Altogether, I have 5 pieces of 6. So this is an example of finding a common denominator. Now a reciprocal, when we have a fraction like that fraction we just looked at, 1/2, the reciprocal does 2 things. It flips it over, so meaning the 2 goes on top and the 1 goes on bottom, but also I want you to recognize that a number like 1/2 times its reciprocal gives us, well, 1 times 2 is 2. 2 times 1 is 2. So it gives us 1. So 2 things about a reciprocal. It is the flip of a fraction, and when you multiply it together, it equals 1. Now, like terms, if we're gathering up things together, like say we have 2 apples plus 7 bananas, bananas plus 4 more apples. Well, we can only gather the apples with the apples, and the bananas have to be listed differently. So if I'm going to gather like terms, I would keep the apples with the apples. So what is, let's see, 2 apples and 4 apples, that is 6 apples. Plus, well, then I can just list the bananas because I can't combine them with them, but I still have them. They didn't go anywhere. 7 bananas. 7 bananas. And that's the same way if we use like variables. I could have said 2 x's plus 7 y's plus 4 x's. And then when I gathered up the ones that are alike, well, there's 2 x's there and 4 x's there. That would have given me 6 x's. And then I didn't lose my 7 y's. They just can't be combined, so I just list them. 7y. All right, so moving on here, let's see, percent. Well, the literal definition of percent, we already looked at. We know that the word per means for every or for each. And we know that the word cent means 100. So percent literally means for every 100. It is that special fraction or proportion or ratio that has 100 in the denominator. Okay, so whatever it is, it's over 100. Next, we are looking at some rules for signs. So if I have a positive number and I multiply it times a positive number, that will always result in a positive number. And if I have a negative and I multiply it times a negative, that will also result in a positive number. But if I mix them up, if I've got a negative times a positive, that will result in a negative. So one way that I've thought about it before is if you have no negatives, well, there's no reason for it to be negative, but if you have an even number of negatives, like here there's 2 of them, that's even, that will give you a positive. And if you've got an odd number of negatives, like here there's only 1 negative, that will give you a negative. Okay? But just remember, a negative and a negative is a positive, and a negative and a positive is a negative. So remember that. If we've got an even number of negatives, either 0, 2, 4, 6, 24 negatives in a problem, then you're going to get with a positive result. But if there's an odd number, it's going to keep flipping it over to the negative. All right, let's see. Converting fractions to decimals and fractions to percent. So if I have a fraction, let's see, like 3/4. And I'm going to convert that to a decimal. Remember that the first thing, let's see, fractions to decimals, I know I can use long division, right? So 3/4, I know that it's 3 divided by 4, and it's not big enough. 3 is not big enough, so I'm going to have to expand that out with some decimals here. And when I put the decimal there, I want to line it up right there. Well, 4 doesn't go into 3, but it does go into 30 7 times, and that gives me 28. If I subtract that, I got 2 left over. I bring down the copy of the 0, and 4 goes into 25 times. So I know that I've got 75.75. That takes me from a fraction to a percent. Now to a decimal. Now if I want to go from a fraction to a percent, well, I'm going to use that long division to get to the decimal, and then I'm going to multiply it by 100. So I'm going to move it 2 to the right. So here I used long division, and I found that 3/4 is the same as 0.75. So if I use that multiplying by 100 and I move it over 2 spaces, well, that turned it into 75, and I have to put the percent symbol with it. So let's remember, to convert a fraction to a decimal, you use long division. And if I want to convert it to a percent, I then take that and I move the decimal 2 places over. Okay, now let's see, what if I have a decimal and I want to make it to a fraction? Okay, well, if I want a decimal and I want to move it to a fraction, I'm going to put it over, a lot of times 100, but let's look at it. If I have something like 0.23, well, I know that, let's see, this is the 10th place and this is the 100th place. So I know I'm going to put that one over 100. So 23/100, and that is my fraction. But let's say that I have one like 0.8. Well, this one, I just move over 1 place. I'm just to the 10th place. Well, I can just put that one over 10. But I do need to remember that I can always reduce it. When I reduce it, I find something that I can divide out of both the top and the bottom. So in this case, let's see, I think it's 2. So let's divide the top by 2, and let's divide the bottom by 2, and get 4/5. Okay, so there we go. And I want you to see that it works the same way if it's something bigger than that. Okay, if it's bigger. So like, what if I have 0.287? Okay, 0.287. Well, I just look at that again. I have the 10th place, the 100th place, the 1000th place. So there's 3 places. So I know I'm going to use 3 zeros. I'm going to go out to the thousands. So 287 divided by 1,000. And then I would just reduce that. Okay, but now what if I start with my decimal and I want to change it to a percent. Well, that's easy because we kind of just did it in the one before, right? Let's see here, when we got it to a decimal and then we moved it 2 places to the right. So let's look at that again. And we know that we're going to do it to a percent. What we're going to do is from a decimal to a percent, we're going to multiply by 100. So we will move the decimal 2 places to the right, and we're going to add that special percent sign. So let's see the examples that we have. I had 0.23, and if I move it 2 places, then I know I've got 23%. If I have that 0.8, well, and I move 2 places, 1, 2, well, we got to remember, if I have that empty bucket there, I got to put a 0 in it. So what I have there is not 8%, but 80%. And then finally, what would that look like if I had this last one, which was 0.287? Well, same thing. We're going to move it 2 places, 1, 2, because we're only going to move it to the 100th. We're going to move it because percent means per 100, right? So that means we're going to have 28.7%. All right, so that is how we do the first page. Well, a part of the first page, I think. I think maybe I've spaced mine out a little bit differently for the sake of doing it. Okay, simplify or reduce fractions. We talked about that already, but if I have a fraction, and let's say it's something like 4/8. I'm going to look for something that I can pull a number out of the top and the bottom, the same number out of the top and the bottom, and to make it smaller. So let me do 2 examples here. Let's do this. That's messy. That's messy. Let me write that a little bit better. Let's do 5/10 and 4/8. So 4/8, I notice that they're both even numbers. So if I notice right away that 4 comes out of both of them, I can jump straight to 4. But say I don't notice that right away and I just notice they're even, I could go ahead and divide both by 2 because all even numbers can be divided by 2. So 4 divided by 2 is 2, and 8 divided by 2 is 4. Well, I find myself in that same situation again. They're both even, so I can divide them both by 2 again. Okay, let me get that out of the way so I have room. I can divide them both by 2 again. So 2 divided by 2 is 1, and 4 divided by 2 is 2. And now they're not both even. 1 is the simplest of anything, so I know that that is now reduced. Okay, well, what would I do if it's not even? So let's say I had 5 out of, let's just change that to 20. Well, if it ends in a 5 or a 0, I can remember back to skip counting when I was in grade school, 5, 10, 15, 20, 25. All of those numbers have 5 as a factor. So I'm going to just start with doing 5s. Like 5 divided by 5 is simply 1, and 20 divided by 5 is 4. Well, I can't get any smaller than 1 of something, so that's done already. So when you reduce, what you're doing is you're dividing, you're going to divide the top and bottom by the same number. By the same number to make it smaller. And one trick is that if it's even, you know you can always do by 2s. And if it ends in 5 or 0, you know that you can go by 5s. Combining like terms, well, I think that's on there twice because I think we already did that. But combining like terms just means that you can add things that are the same. So like if I have something with x's, like x plus 2x, I know that that can be 3x. But if I have something like x plus 2y's, I can't combine those. They're not the same thing. So that would just have to stay x and 2y. All right. Add or subtract fractions and decimals. So the big thing that we need to know is when we are adding or subtracting fractions or decimals, we must have a common denominator, always. And if you recall back to the lesson, that's because if we had something like 1/2 plus 3/4, and we tried to just go straight across and like add them together, we would actually be going against our order of operations, because remember, this division bar, that fraction bar is just a fancy way of saying divided by. So we have to divide before we can add or subtract, but we can get around that if they've got the same denominator. So I could take this, and I can use a couple different methods, but one method that I like is the easiest common denominator, where I'll just look at my 2 and my 4, and I'll multiply them together and get 8. So I know that 8 is going to be the common denominator I'm going to use. And when I do that, let's see, I took the 2 times 4 to turn it into 8, and I took the 4 times 2 to turn it into 8. So this could be the same thing as 4 over 8 plus 6 over 8, which gives us 10 over 8. Now, of course, I would reduce that by taking both by 2 and just getting 5 over 4. And that's one way of doing it. That's the easiest common denominator. But remember, there's another way we could have done it. I could have done, if I had 1/2 and 3/4, I could have done the least common denominator. And when I have the least common denominator, I would look at the 2 and the 4, and I would say, well, I've got a 2 and I've got a 4. If I take them times 1, that gives me 2, and that gives me 4. Let's see, if I take them times 2, 2 times 2 is 4, 2 times 4 is 8. If I take them times 3, I've got 6 and 12. But wait, I've gone far enough, because I found a common, they each have 4 right here. When I took them times 1 or times 2, so this was the 2's and this was the 4's. So when I took my 2 times 2, I got 4. And when I took my 4 times 1, I also got 4. So my least common denominator there is a 4, right? So what I would do there is I would just say, well, I'm going to turn my 2 into a 4. So I'm going to take that times 2, and get 2 over 4, and then I can leave the other one alone, or I can take it times 1. But now they both got 4, which gives me 5 over 4. So notice they're the same thing. When you use the least common denominator method, you won't have to reduce as much, okay? However, sometimes they're not easy to spot. And it doesn't matter to me which way you go, as long as you remember that when you are adding or subtracting fractions, you must always have a common denominator. Okay, let's move on. I'm going to go ahead and clear some of this space, so hopefully you got all that. Let's clear some of this space out. Looking at multiplying or dividing, well, there are two different methods. I'm not going to put that in the same color because there are two different methods. Let's see, when I multiply fractions, I just multiply straight across. Okay, I'm going to multiply straight across. So let's make this bigger here. Let's look at this. Multiply straight across. So let's say I have 6 over 4 times 2 over 3. Well, multiplying straight across, I'd take 6 times 2, and I would take 4 times 3. So 6 times 2 is 12, and 4 times 3 is 12. That just so happens that this turns out to be 1. Okay, that's good. So multiplying, easy peasy, we've got this. But now dividing. Dividing is a different can of worms. So remember, when we're dividing, we must use the reciprocal. And remember, the reciprocal is the flip of the fraction. So let's look at this same one, but a little bit differently now. Let's say I have 6 over 4, and this time it's divided by 2 over 3. Divided by 2 over 3. Well, I can't just go straight across. That's not going to work. But what I'm going to do is I'm going to use the reciprocal of that second number. Okay, and you can go back and rewatch our lessons if you need to, if that'll help. But I've got 6 over 4. So I'm going to keep it, the first one. I'm going to change to multiplication, and then I'm going to flip the second one and use that reciprocal. So now I've got a multiplication problem. I've rewritten this as multiplication, and I can just go straight across, correct? So 6 times 3 is 18. 4 times 2 is 8. And then I could, of course, reduce that. Let's see, I could reduce that by 2's and get 9 over 4. And that would be my answer. All right, so let's see. Let's move on now to multiply and divide with decimals. Okay, so this time we're going to do decimals. Well, we're going to use, when we multiply and divide with decimals, it's the exact same as with any other number. So let's say that I have, so we're going to use those same methods, but we're going to make sure that we count our decimal places. And this is something you did in grade school. So we didn't really work on it much here, but let's look at this. So let's say I had 0.2 times 0.4. Well, what is 2 times 4? That's simply 8. Okay, but let's see, how many decimal places do I have? I have one here, and I have one here. So that means I need this to go have 1, 2 decimal places. 0.08. So let's just look at a different example here. Let's say, what if I had 0.7 times 0.2? Well, this 7 times 2 gives me 14, and I have my decimal place here, my decimal place here. So that's still, let's see, this goes over one place and this goes over one place. So I know I've got to go 1, 2 places over. So this one is 0.14. If I had 1.1 times 0.3, well, 3 times 1 is 3. 3 times 3, how many? I got a 1 decimal spot here and 1 decimal spot here. There we go. Does that give us enough examples? So you just do it the same way, but you count how many decimal places. Maybe it would be helpful if I did one that had a different number of decimal places. Let's say like 1.25 times, well, let's just do a regular, let's do 6. Okay, so 5 times 6 is 30. So I put my 0 and my 3, 12, 13, 14, 15, 7. So I've got 750, and I'm looking up here, and this decimal goes 1, 2 places. So I know I'm going to have 1, 2 places here. So my answer is 7.50, or just 7.5. So that is multiplying decimals. Okay, that is multiplying decimals. Well, the same thing basically, well, when you, let's see, that's multiply. Now, when we want to divide decimals, the way that we kind of looked at it here, let's say we're going to divide with decimals. Mostly in the context of what we've been working on is we've been using long division. So let's say I had like, let's say I had 0.4 and I want to divide that by 2. Well, I've got 0.4 divided by 2. Wherever my decimal is down here underneath, I need it to be in the top. And then 2 just goes into 4 2 times. So my answer to that is 0.2. So let's see, we've run into it a lot in the case of fractions, where it's been like 6 divided by I don't like that one. Let me give a different one. Let's do one like, let's do 75 divided by 100. It's an easy one to work with for sake of examples here. Well, I know that this fraction bar is the same thing as saying divided by. So I'm going to do 75 divided by 100. Well, 75 is not big enough to fit any hundreds in there. So I know I'm going to need to add some decimal points. Wherever my decimal is here, I want it to be there because I want everything to line up. So 75 isn't big enough to fit 100 in there, but 750 is. I can put 7 of them in there. So 7 times 100 is 700. When I subtract that, I have 50 remaining. So I'm not done. I have to expand that with another 0 and bring it down, copy it. So now I ask myself, 100 goes into 500 how many times? That is 5. 5 times 100 is 500. Now when I subtract, I get no remainder, so I know I'm done, and my answer is 0.75. So when we're dividing with decimals, we need to remember to line it up. I think that's where some of the only mistakes really came from with that. All right, so let's back out of here and let's see, what is our next thing? The associative property of addition and of multiplication. Well, quite simply, the associative property of addition means we can change its associations. So if I have A plus B, and then I add C to it, I'm going to have the same value as if I have my A, and then I add to that the sum of B plus C. I just changed the parentheses around. And if I look at it for multiplication, it's very similar. That means that I can have A times B, and then I can multiply C to that. And it'll give me the same thing as if I start with A, and then multiply the product of B and C to that. And again, we explained all of these in our lessons. If you're feeling hazy about it, go back, look at them again. The commutative property of addition. Well, remember we saw that guy Josh, and he had to take the subway to his internship, and it meant that he could go in one direction on the way to work and a different direction on the way home. So the commutative property of addition means that if we take A and we add to that B, we will get the same value. The same value as if we start with B and add to it A. And if we look at that in terms of multiplication, very similar. I can take A times B, and it will give me the same thing as if I have B and multiply it times A, right? So 2 times 3 is the same thing as 3 times 2. And then our identity properties. So identity of addition. Well, that's just saying I have A, and I want to add to it something that lets me keep it as A. Well, what can I add to any number that doesn't change the value? Well, 0. Anything plus 0 stays the same. Multiplication's a little bit different, but we're trying to achieve the same thing. I have A, and I want to multiply something to it that lets me keep A with the same identity. It's not 0, because when we multiply something by 0, we get 0. But it is 1. If I take anything times 1, that just means one copy of that. Just a single one of those things. So it stays as A. So that's kind of a rundown of that next part. So the last property that we're gonna talk about is the distributive property. And the distributive property looks a little different because we've got A times B plus C, right? So we've got some multiplication happening, and inside the parentheses, we've got some addition happening. So we can't use the associative and we can't use the commutative. But what this tells us is that I can multiply across. I can take A times the B as long as I also take A times the C, right? So that means that A times the quantity of B plus C is the same thing as A times B, and add to that A times C. Okay, so that's the last one of our properties, the distributive property. Again, I encourage you to go back and rewatch the lessons if some of this doesn't sound very familiar or if you don't feel confident about them. All right, now the next part of your review says you should be able to work these example problems. So let's work through these example problems together. Let's work through these example problems together and see what we get. So first one, these are numbered, but you can ignore that. The numbers don't mean anything. That just means I copied them from another document, but they have been changed. So here, what I want to remember is that this division bar, this fraction bar, is the same thing as saying divided by. So what I really have is negative 72 divided by negative 8. Well, I remember back to my rules of rational numbers, and I know that a negative divided by a negative, let's see, there's an even number of negatives, so I know it's going to be positive. So I don't have to worry about those signs anymore, right? Just let's forget about those. And let's just look at the 72 divided by 8. Well, we know that 72 divided by 8 is simply 9. And again, we already determined that it would be positive. So let's look at the next one. 7 times negative 3. Let's remember those. Let's go ahead and remember our rules. Well, our rules are that if we have a negative and a negative, then it's going to equal a negative. We know if we have a positive and a positive, it will equal a positive. And we know if we multiply a combination of a negative and a positive, that we will get a negative. So what situation are we running into here? Well, here, we're multiplying in a 7 and a 3, but we've got one of them as a negative. So we know our answer is going to be negative. And then we just look at the numbers. 7 times 3 is 21. Easy peasy. All right, let's look at the other one. Oh, let's undo that. Let's look over here at some of these. And again, like I said, we can just ignore those numbers. They don't mean anything. Okay, so 0.2 times 0.4. Well, they're both positive, so I know I'm not going to be worrying about any signs. But I've got 0.2 times 0.4. Well, 2 times 4 is 8. And then I'm going to see how many decimal places am I looking at. Well, I've got a decimal place here, and I've got a decimal place here. So I know I'm going to go 1, 2 places. So my answer is 0.08. And let's see, the next one is 4/9 divided by 3/2. Okay, well, a couple things are going on right here. First thing, I need to remember that these fractions are the same thing as division bars, okay? They're the same thing as division bars. So what I know, I am dividing fractions. When I divide fractions, that's when I want to keep, change, and flip. I know some of your teachers in elementary school taught you that, so I'm just going to go ahead and remind you that that's what you do. So my first term, I'm going to keep 4 divided by 9. I'm going to change that division to multiplication, and then I'm going to flip, or I'm going to use the reciprocal. I'm going to multiply by the reciprocal. And then since now I'm doing multiplication, I can multiply straight across both the top and the bottom. So 4 times 2 is 8, and 9 times 3 is 27. 8/27 is my answer. Easy peasy. All right, a Sonic car hop served 12 customers in 1/4 of a day. At that rate, how many customers could they help in one day? All right, so what I have is I know that they've got, let's find the important information here. First, it's asking me how many can I find in one day? And right now they're serving 12 customers per 1/4 of a day. So that's a rate. And we want to know how many they can do in a day. Well, if they've got 12 customers per quarter of a day, so remember per can be divided by or over. That looks funky because there's a fraction bar and then another fraction bar. But if you remember our lesson on dividing fractions, we know that this can be just rewritten. Dividing fractions can be rewritten as multiplying the reciprocal. So if I have 12 or 12 over 1, and I multiply by the reciprocal of 1/4, that is 4 over 1. Well, that's easy peasy. I can go straight across. 12 times 4 is 48, and 1 times 1 is 1. So that is just 48, 48 customers a day, right? Okay, I think we're getting the hang of this rate thing. Let's try it again. So a teenager has 12 favorite games on their phone when they discover storage is full. They have to delete 25% of the games. How many games will they have deleted? Oh, okay, no more rates. This is something different. So what it's asking us to do is to take those 12 games. We've got 12 games, and we need to know what is 25% of them. So what is 25%? Let's see. Let's write this a different way. Let's say what is 25% of 12? Well, that's one of our clues. That's one of our clues, our math clue words, and we had it in some of our lessons. We need to remember that that means multiply. So let's multiply those two numbers together, and there's a couple strategies we can use. One, we could turn 25% into a fraction, or we could turn it into a decimal. I'm looking at 25%, and that's one that I just kind of know because I've used it a lot. So I think what I'm going to do is I'm going to turn it into a fraction, and I know that 25% is the same thing as 1/4. 1/4 times 12, or 12 over 1. Well, let's just use our strategies for multiplying fractions and go straight across. Right? We'll go straight across. So 12 times 1 is 12. 4 times 1 is 4. And then we see that 12 divided by 4 is just 3. So we know that they're going to have to delete 3 games. They're going to lose 3 games. Now, alternatively, you could have done that by turning it into a decimal. And you could have taken 0.25 times 12. Well, and to do that, you would just do, let's see, 0.25 times 12. See, 2 times 0.25 would have been 50, and 1 times 25 is 25, 0, 0, 3. And then I look at this and I notice there are 2 decimal places, which, look at that, handy dandy. That can verify our answer because these are both the same, right? I got 3 either way, whether I turned it into a decimal or a percent. Okay. In PE class, 2/3 of the 30 students ran a mile. Of the students who ran a mile, 10% of them ran 2 miles. How many students ran 2 miles? So we got a lot of information. We got 30 students. Let me organize this. Let's see. I've got 30 students. Of those 30 students, 2/3 ran 1 mile. And let's see, 10% of 2/3 ran 2 miles. Okay. And it wants to know how many students ran 2 miles. Well, good thing we just set that up right here. We know that it's going to be 10% of 2/3. And from the problem before, we know that of is a code word for multiply, right? For multiply. So we're kind of doing the same thing that we just were. We know that 10% times 2/3 is what we're looking for. So we can do it as a decimal. 10% written as a decimal is 0.10 or 0.1. times 2/3. Or we can say 10% written as a fraction is 10 over 100, right? We know percent times 2/3. That looks like the easiest way, don't you think? Because they're both fractions now. And I know I can multiply straight across. So 10 times 2 is 20. And 100 times 3 is 300. Well, if I reduce that, if I divide both the top and the bottom by 10, that gets rid of that. So I've got 2, let's see, let me write that. I've got 2 out of the 30 students ran 2 miles. And it wants to know how many students? Well, 2 students. So 2 students ran 2 miles. Let's see, there are some other strategies we could have used for that problem. Let's look at that too. Let's see, if we just kind of thought it through logically, let's do this as a side note. If I have 30 students and I know that 2/3 of them ran a mile, I know that that is times 2/3. So 30 over 1 times 3 over 2 would give me 60 over 3. And 60 divided by 3 is 20, right? So I know that 20 students are how many that ran a mile. And then we know that of those that ran a mile, 10% ran 2 miles. So 10%, so I got 20 students times 10%, which is 10 over 100. That's how many ran a mile, right? So if I multiplied that straight across, I would end up with 20 times 10 is 200 divided by 100. And again, if I divided by 10 and by 10 again, I would still end up with 2 divided by 1, which is, of course, verifying that it was 2 students. So those are 2 different ways to kind of think about it, but both logically will give you the same answer. All right, this is getting messy, but let's just kind of hide that part. And now let's look at it. Jordan bought 2 bundles of rope. The first bundle of rope is 80.7 meters of rope, and the second bundle is 9.6. And it wants to know how many more meters of rope is the first bundle, does the first bundle have? Well, if I'm comparing them and one of them has more, I know I need to find the difference. So what I'm going to do is I'm going to take my 80.7, find the difference between 9.6. So I'm going to be subtracting. 7 minus 6 is 1. 80 minus 9 is 71. So I know that it is 71 meters more. So in this one, I had to identify that I'm finding a difference because I'm comparing the two and one is more than the other. All right. A pulley can move 86.3 feet of chain per minute. How many feet of chain will the pulley move in 3 minutes? Okay. All right. Well, how many? So I'm seeing per minute, which makes me think I'm dealing with a rate again. And I know in 1 minute, it moves. In 1 minute, it's 86.3 feet. But I don't want to know for 1 minute. I want to know for 3 minutes. So that's going to be 3 times as many minutes, right? So 3 times as many minutes. I'm going to take that times 3. Let's see, 3 times 3 is 9. That's 18. Carry the 1, 25. So I have 258.9 feet of chain in 3 minutes. Because, let's see, in 1 minute, let's see if I did minutes against feet. Let's see. In 1 minute, I did 86.3. And I want to know what would that be equal to in 3 minutes. Well, I think it's 258.9. And I would check that by saying, well, this I took times 3. So if this I take times 3, and that's exactly what we did up here. So yeah, logically that's right. That's right. So we're going to say it's 258.9 feet. Almost done. Almost done working through all of these. Jacqueline, that's my daughter-in-law's name. Jacqueline has 10 pairs of socks in her laundry basket. So she has 10 total pairs. She has 10 pairs. So 10 pairs of socks. 3 are black. 4 are gray. And 3, let's see if I can't write this a little bit better. She's got 10 pair, and 3 are black. 4 are gray. 3 are white. And we want to know what fraction of the socks are either black or gray. Well, black, I've got 3 out of the 10 of them. And I can also have if they're gray, and that's 4 out of the 10 of them. So I just want to add those together to see the total. Well, 3 plus 4 is 7 pieces of 10, or 7 out of 10. I can just leave it just like that. They were a common denominator, so I was indeed allowed to add them just as they were. All right, Mrs. Witt's math class. 1/3 of the students received A's, and 1/4 of my students received B's on their test. So let's see, 1/3 got A's, and 1/4 got B's. And let's see what we want to do. We want to know what fraction of the total students received either an A or a B. Well, I know that 1/3 of them got an A and 1/4 of them got a B. So if I added those together, that would tell me how many I got that had either an A or a B, right? So can I just add them? I can't just add them because I need to have a common denominator. And right now they don't have common denominators. Common denominator. Right now one's got a 3 and one's got a 4. Well, one method is to find the easiest common denominator. So I'm going to take 3 times 4 and get 12. So I know that I'm going to be adding something with 12 on the bottom. Well, how did 3 turn into 12? I took it times 4. And how did 4 turn into 12? I took it times 3. So looking at the top, 4 times 1 gives me 4. 3 times 1 gives me 3. Now I can add them and find out how many out of 12. Well, 4 pieces of 12 and 3 pieces of 12 altogether get 7/12. So what fraction of the total got either an A or a B? 7/12 got either an A or a B on the test. Our Linda has a poster board that is 8 1/2 inches long. She cuts it into 4 equal strips. How many inches long is each strip of poster board? Well, when I cut something into equal strips, or I share something in equal pieces, that means I am going to divide. So let's see, the whole thing is 8 1/2, and I'm going to divide that into 4 equal strips. Well, there's a couple different ways I could do this. I kind of like the idea of turning that 8 1/2 into an improper fraction. So let's see, 8 times 2 is 16 plus 1 is 17. So I could say this is the same as 17 over 2 divided by 4. Now remember, what is the deal when I am dividing fractions? When I divide fractions, I want to keep, change the operation, and flip the second fraction, which means I just want to multiply by the reciprocal. So my first fraction is 17 over 2. I'm going to keep that. And then instead of dividing by 4, I'm going to multiply by the reciprocal. So instead of divided by 4, I'm going to multiply by 1/4. So across the top, we just go straight across the top, straight across the bottom. Let's see, 17 times 1 is 17. 2 times 4 is 8. So I know that each strip is 17/8 of an inch. And I could go ahead and just figure out that that is 17 divided by 8 is 2 1/8. 2 1/8 inch. So either one of these is an accurate answer. It is 17/8 of an inch or 2 1/8 of an inch. Either one of those is an accurate answer. One is given as an improper fraction, and one you went ahead and made it a mixed number. Either one is okay. They mean the same thing. Now our last question. We are here finally. We are at our last question, and everyone wants to know which one is a better buy. So I'm thinking we're going to have to compare, and we might want to find the unit price. So we're going to compare the unit price of these two items.